I'm one of the senior engineers here at Ricoh, working both on supporting the team with the metal binder jetting development and also with the printing service we offer here from the UK. We'll say in terms of how the software is helping our 3D printing business, when it comes to the metal binder jetting technology, it's really down to helping our customer, not just, we are exploring new application with our new technology, and it's not just about printing. As Masato said during the webinar, we want to be provide a full solution to our customer. So having access to this type of tool is enabling us to also supporting our customer with the development of more efficient and more effective design for their application. So by knowing what they want to achieve, we can also support them in creating the right design for the right application, especially as Masato mentioned during the webinar, a lot of the application we are targeting involves fluid management. And so the ToffeeX solution is really the right solution to support this application. And very similar, this is also applicable to our print service business. Again, some of the customer we are supporting with our print part service operate in sectors where fluid management application are really key. And again, being able to offer solution in terms of design are an added value for those customers, and provide an added value than just printing parts.
That's great, Enrico. Thank you very much for sharing both on the vision, on the direction, but also much closer, let's say, testimonial on the user, on your customer experience and the value you're adding to them. But more, a bit more on the, let's say, on the adoption also of ToffeeX. Probably. Maybe it's a question more suitable for Masato, which is the main user of ToffeeX. It's like how ToffeeX integrate with your existing processes.
ToffeeX is used as a DFAM to improve functionality. Now we are also modifying the model for successful sintering as an additional design process. But I believe in the future, we can apply the new function of manufacturing constraints, as Marco explained, to our binder jetting as well. So we will simplify the design workflow. Yeah, that's it.
Yeah, thank you, Masato. So in this, what did you like the most? What is the feature you like? What did you like the most about using ToffeeX?
I can raise three benefits. The first point is incredible fast computational time. I have experience with topology optimization of structural component, but I had understood that topology optimization for thermal fluids was still at an academic stage. The cases I introduced this time were all completed within a few hours, and this was the most surprising point for me. The second point is software can be handled even by non-experts. As I mentioned, my specialty is mechanical design, and I'm not an expert in thermal fluids, but I was able to learn how to use ToffeeX in a short period, about 2 or 3 weeks. It seems that conditions were set to be as simple as possible, I think. The third point is solo support. Any questions were resolved quickly via email or web chat. The software updates also incorporate our request quickly.
Yeah, that's great, Masato. Thank you very much for this. And are you planning to use any of the new features for your design activities?
I'm so interested in the functionality of manufacturing constraints, like overhang constraints. The manufacturing constraints can further simplify our current design process, which would be a significant benefit for me and our customers.
Great. Thank you, Masato. Thank you for taking this question really on the usage, on your experience of using the software. So maybe a bit more on a general topic. So for both of you, like more in general, how do you see, let's say, the generative design evolution, the generative design landscape evolving in engineering?
Maybe I go first. Just
Thanks.
couple of points from me. Some idea. I think first thing is probably the computational power is something that we probably see evolving in future, speeding up this iterative process, and so the user can be focusing more on defining the problems, and the software will be there to sort of, again, it's a bit of a co-creation process where the software, by speeding up the process, will help coming with the right design, optimized design in quicker time, and again speeding up the development process of new products or more performing product. And I think we see the evolution of your tool, going for purely an AM tool to considering more traditional processes. And I think going forward, it will be, really nice to see integrating other decision-making factors into the software, like, for example, a cost analysis or a life cycle analysis of the product. And I think this is really something that, again, we probably see more in future, where the metrics will not based purely on physics and the outcome in terms of optimization, but we have a more global picture that will help the user decide which is the most appropriate solution, not just from a performance point of view, but also from a cost perspective and from a end-to-end life cycle analysis.
Yeah, great, Enrico. Thank you very much. This is really, let's say, aligned with our vision. We believe that finding an optimal design, as you said, is not only about finding the best balance between pressure losses, heat exchange, or manufacturing technique, but it needs another layer. It needs also really balancing cost of manufacturing and operational costs. So the efficiency, physics, strict efficiency has to balance also with the efficiency of producing or manufacturing go to market. So adding a tooling tool for costing evaluation will give a much broader and comprehensive and informed, let's say, design of experiment. So for the user to pick the best one. Yeah, and Masato, what do you think about also this, the evolution in the landscape of additive manufacturing for engineering?
It's a bit difficult question for me. Generative design is an innovative technology that significantly lower the barriers to entry in engineering. And personally, as I mentioned, having experienced higher barriers in the field of thermal fluids, but generative design has enabled me to actively engage in this area. Yeah, that's it.
Yeah, thank you for this as well.